Hi, Karl from Hyrel here. Another one of our little videos. Hopefully we got some good information for you today. I wanted to walk through the evolution of using a laser in the system. 15 years ago we started the company. About 14 years ago I realized that a diode laser would be very easy for us to implement. Not really having a specific goal other than we had a need to do a serial number marking on metal. So what you can see in front of me here is a variety of different versions of the laser, and this was actually one of the first ones we used. Inside here is an 808 nanometer small laser diode. It's mounted to a heat sink. It's a gold heat sink which mounts to this. Very, very sensitive to current. You blow up your diodes if you give them too much current. That's the number one way you can make a laser fail. This is another version of it, and you'll see here we have a readout instead of an analog signal, and this would show voltage and current. And then finally we evolved a little bit more until we got to this smaller package. These diodes conveniently come in 808 and about 1064 nanometers. So that's the infrared spectrum. You can see it when it's cutting, but don't watch the beam. It's a good idea to always wear safety glasses with the right wavelength of blocking whenever you're working with a laser. The damage you can do is instantaneous, and that's never going to be a good thing because the rest of your life you're going to have affected vision problems, or can have that. Besides that, as time went on, the 450 nanometer laser diodes became very popular, and also in mass production they were cheaper and higher power. So we were able to get and build these units here that have single laser diodes in them, and these are really about 5 optical watts if you get everything right. Some people will make claims, like on this one here, it has a little check mark and says it's 7 watts. And this one here has a check mark and says it's 15 watts. I also have some beachfront property in the desert I'm willing to sell you. Do not believe what these are marked at. The optical power is 95% of the time significantly lower than what it's marked at. We have a small version here that is for 405 nanometers, and that one is used for cross-linking also, and some people need that lower frequency, the shorter wavelength, to cross-link their materials. Finally, we have what is called a combinatorial or dual or triple diode. And so what happens is there's a diode that's mounted in the top, and it comes down, and there's a little mirror, and it's a special mirror. There's a second diode that's mounted on the side, and that mirror is a one-way mirror. So coming from the top, the signal keeps going through, and from the side, it bounces off of here and reflects down and joins the beam. So they add, it's a beam combiner, and that doubles the power almost. There's a little bit of energy lost and a little bit of diffraction, and it will come down here, and then it's focused with a second lens inside of here. And they also did something really smart, and that is they added an input here. So you can see that part of the lens is here, but that's your working lens. This is to block the air. So when the air comes in, it blows through here and out the nozzle, so that that beam where it's cutting, it will blow that smoke and debris out of the way, and that can be very helpful. I personally never cut plastic with my laser. Even though it's possible with some of the colored plastics, you're creating fumes of hydrocarbons, of polymers that are not good for you. So I highly recommend that you only go to a really good exhausted area and make sure you have good filters. These people that show you cutting plastic in their kitchen with some refiltration system, all of my experience says that's not very good. While you can juggle chainsaws, it's not recommended. Okay, so that's a brief overview of where we're at. I'll show you a couple of marks that can be done with the latest laser. That would be this one right here. This one is truly 15 optical watts. And we made a couple of marks here. So this is a stainless steel cover for a box that we wanted to mark. And here you can see the serial number. And this was done at 800 millimeters per minute of motion, and full power on that unit. And if you run your finger over it, you actually will feel that it's cut into the metal. So it's had a relief to it, which for stainless steel is pretty good, in my opinion. You can also see up here a similar mark. And this mark was anodized, black anodized aluminum. So you can get an idea of what it's like for doing aluminum. You can cut different materials with it, but again, anything that generates fumes, any plastics or organic materials, not a good idea to cut them with this machine. If you go get, or a CO2 system, unless you go ahead and implement a really, really good exhaust system. Okay, so one of the things also I wanted to cover in this video quickly is what this machine's for. Because you're like, well, it's got a laser and you can make some marks, but I'm not selling it as a marking machine. It is an experimental platform, which means you can do different things. You can use some light to expose your polymer. You can use, if you move it down and defocus, you can still get an intense focus light. You can make patterns out of it. There's different things you can do. Many of our customers have found lots of creative ways to accomplish their goals. You also, because of the modular head system, are able to mix and match. You can reconfigure the machine in literally minutes. I will give you a good example of that. Right now in this machine we have a Uvada light pen, which is used specifically for cross-linking resin. This comes in 365, 405, and 450 nanometer wavelengths. And the light comes out of the end, and it literally works with the same exact code. And I will just run this here. Let's see if it works. It comes with the same code that we run our laser or our inkjet, so you can test it multiple ways. Now, come on back. Yeah, sorry. I'm going to do this, and it doesn't look like there's much of a beam, but if you come over here and put your camera, you can see that the blue light. So this particular one is 450 nanometers. If that were 365 nanometers, which is available, that would be ultraviolet, and you do not want to watch the ultraviolet. And that's why we ship every Hydra 21 with this blocking, UV blocking polycarbonate, not acrylic, polycarbonate. Very durable, very strong on all four sides of the machine. So it comes ready to go to work in your UV cross-linking applications. Another thing that we have done, this is an example, but this is a bulk resin feeder. You just fill it up with your resin, we pressurize it to a few PSI, and then it goes to your direct ink writing. When you get done with your direct ink writing, you add a pass with your UV pen, and voila, we have now created a structure from a polymer that's liquid and created a solid from it. And you can mix and match. You can use another head so that you come out with a clay, and then a polymer, and then we cross-link, or we can do FDM, and then a polymer, and then a cross-link. So there's many, many different configurations. Hopefully that gives you a little bit of insight into what the printer is meant for, and it helps you imagineer ways to use it. I hope you're having a good day, and we'll talk to you soon. Thanks.